Hello students, welcome back. In last lecture we have studied about electric field lines and electric field, right? So we will be continuing with some of the problems on electric field lines, how they will be asking in exams, okay? Let us take an example. Which of the following figures figures represent the electric field lines due to a single negative charge. Single negative charge. Figures are: one is this is A option, B option is C option, and the D option is this is the question. Which of the following figures represent the electric field lines due to a single negative charge? Okay. Now, what we have studied yesterday's class, that positive charge, from the positive charge, field lines will start producing outwards, and in negative charge, the field lines will be coming towards it, right? Inward direction. So we have studied this one, and we also studied those will be in divergent, they are getting outside. First one, how the field lines are going, they are in outward direction, which are perpendicular to the surface, are from the originate from the surface, right? Second, all the field lines are coming towards the negative charge, right? Inward direction. In third one, negative charge is there and the field lines are there which are parallel to each other from a single point charge. It is what? Single negative charge. It is single charge. Single charge means it should be generating its field lines outwards, right? So this is anyhow wrong, and this is also wrong. In positive direction they will be moving outward, and in D option there is a field lines which is field lines in the direction of right side, right? They are uniform parallel to each other, they are uniform and they are moving parallel to each other, and there is a negative charge in between. So this can't be true. So that's why B is our option. B is our option. So this type of questions they will give in a CET exam on the electric field lines. Okay. Next, we will take another example. It is an easy one, right? It is an easy one. Now we will do a somewhat okay. I will take the next problem. Okay. Question is, which of the following figures correctly shows the top view of a sketch of electric field lines for a uniformly charged hollow cylinder as shown in figure? They are given a figure like this is a cylinder. Okay. Just time drawing the figure. Okay, they have given a hollow cylinder. It is a hollow cylinder and the charge is on that one, positive charge. Okay. Now they are asking what will be the top view in those figures. Okay, they are given the options in the form of figure. We have to tell the top view. मतलब हमने सिलेंडर लिया है, ठीक है, सिलेंडर को ऊपर से देखेंगे आप. We will be seeing from the top how the field lines will generate. How the field line, while looking from the top of a cylinder, how the field lines will look. Okay. Now, options are, from the top we can see this is a circle, right? These are all positive charge. On the surface also positive charge. Okay. Now the figure, first option will be like this. This is the first option. Second option. Third option. Fourth option. Here one is coming inwards, one is going outwards, one is coming inside, another one is going outwards. Like this. Now tell me which one is correct. करना है तुम्हें खुद से सॉल्व, ठीक है, मैं बता दूंगा, but you have to try by yourself also. How can we tell which one is correct? Now, from the last class, we have remember that one. Electric field lines will always perpendicular to the surface. Electric field lines is always perpendicular to the charge, means where the charge is, or you can say on the surface there is charge, means electric field will be like perpendicular to that one. Okay, means If I see the cylinder from the top view, what I can see, there is a circle, right? From the circle, all there is a positive charge, right? Positive charge है पूरा. अब पॉजिटिव चार्ज में से कैसे दिखेगा हमें, जैसा ऊपर से देखेंगे पॉजिटिव चार्ज है पूरा, ऐसे सोचो, you can think like that is there is a circle with a positive charge, okay, like this. Now how will the field lines will generate? Field lines will be like positive charge it is, that's why they will be moving outward direction. They will be moving outward direction. So that's why which one is correct? Option B is correct, where electric field lines are going outwards, right? Going outwards. First one is going inside. Third one is electric field lines are rotating in this direction. So they are circle. First thing, and this is true or not? Because field lines never intersect and they cannot form a closed loop. We have yesterday, we have also in the last video we have also told that field lines, field lines never form a closed loop. So that's why third is also wrong. And fourth one is getting outward and one is getting inward. So that is also wrong, because it is a positive charge or it is a negative charge, then only one direction the electric field lines will go. They won't be in a two-way direction. Means in one figure they will be in one object. If there is a charge positive, means it will go outward. If I am having a negative charge, it will come inward. If it has some negative charge and some positive charge, it is a neutral, then there is no electric field. Okay, it is a neutral, then it will get cancelled out. So some positive charge means it will act like a positive. More greater negative charge means it is a negative charge object, then it will act like a negative charge object. Okay. Okay, next topic is electric dipole. Okay, next topic is electric dipole. Electric dipole. Electric dipole. The definition is two equal unlike charges, two equal unlike charges separated by a small distance, separated by a small distance, this constitutes a dipole. उसी को हम बोलेंगे कैसे, मतलब we have taken a positive charge and a negative charge. Okay, this is separated by a small distance. This is separated by a small distance that we take as 2m. You can take as X also, D also, R also. Okay, but it is very easy to take to L. Okay, now this length is L and this length is L. So dipole is measured from the middle. Okay, this is a dipole. Two equal unlike charges separated by a small distance is constitutes a dipole. ये बहुत छोटा, ये 2L क्या है? It is a very small length. Okay, ऐसा है 10 to the power minus 10 9 s. ठीक है, तो इसके वजह से it is very small. So now it is called a dipole. Okay, next is now dipole moment. Dipole moment. Dipole moment is given by formula P into charge. Both are equal charges. We are taking one charge Q into 2L. One charge into distance between the two charges. Okay, charge into 2L. This is given by dipole moment. Dipole moment is given by P denoted with the P is equal to Q into 2L. Now electric charge. Now electric charge on a dipole is 0. Electric charge on a dipole is 0. इसके बीच में अगर हम कहीं पे भी चार्ज देंगे that will be 0 because यहाँ नेगेटिव चार्ज यहाँ पॉजिटिव चार्ज क्या हो जाएगा कैंसिल. Okay, and but there will be electric field. Electric field is not 0. Electric field is not 0. क्या हो जाएगा चार्ज 0. डाइपोल में अगर देखेंगे तो चार्ज 0 है बट इलेक्ट्रिक फील्ड इज नॉट 0. इलेक्ट्रिक फील्ड रहेगा. ठीक है, देयर इज अ फोर्स ऑफ अट्रैक्शन. इलेक्ट्रिक फील्ड इज नॉट 0. ये दो इंपॉर्टेंट पॉइंट्स हैं. ठीक है, तो अब यहां पे हम बोल सकते हैं डाइपोल इज अ वेक्टर क्वांटिटी और स्केलर क्वांटिटी. इट इज अ वेक्टर क्वांटिटी. इट इज अ वेक्टर क्वांटिटी. इट इज अ वेक्टर क्वांटिटी. क्यों वेक्टर क्वांटिटी? यहाँ पे चार्ज क्या हो रहा है फ्रॉम नेगेटिव चार्ज टू पॉजिटिव चार्ज. यहाँ पे पॉजिटिव चार्ज नेगेटिव चार्ज को अपनी तरफ खींचेगा. It will pull the negative charge towards it. So that's why the movement will be, or the direction of the dipole movement, it will be in towards the direction of positive charge. Okay, towards the direction of positive charge. कैसे रहेगा इसका डायरेक्शन? फ्रॉम नेगेटिव चार्ज टू पॉजिटिव चार्ज. इट विल बी फ्रॉम नेगेटिव चार्ज टू पॉजिटिव चार्ज. And what will be the SI unit? SI unit of dipole moment is what? This is charge coulomb and that is 12 meter. Meter per coulomb or meter coulomb. Kilometer, you can say meter coulomb, kilometer. Sorry. Okay. What will be the dimension? Dimension क्या हो जाएगा इसका? चार्ज हम लिख सकते हैं एम्पियर टाइम इनटू L, that is length 80 L. Ampere time length. Okay, ampere time length. You can write it as coulomb charge into 2L. ओके, क्या क्या पॉइंट पढ़ा हमने यहाँ पे? टू इक्वल अनलाइक चार्जेस सेपरेटेड बाय स्मॉल डिस्टेंस. अगर दो अनलाइक चार्जेस एंड दे आर इक्वल, then we will be given by the formula that is Q into 2A. ये हमारा डाइपोल मोमेंट है. ठीक है, अब यहाँ पे इसका डायरेक्शन कहाँ पे होगा? डाइपोल मोमेंट का डायरेक्शन फ्रॉम नेगेटिव चार्ज टू पॉजिटिव चार्ज. इट विल बी मूविंग फ्रॉम नेगेटिव चार्ज टू पॉजिटिव चार्ज. It is a vector quantity. Electric charge on a dipole will be 0. Electric field is not 0. Electric field 0 नहीं रहेगा. It is a vector quantity. SI unit of dipole is coulomb meter and dimension is ampere time. Ampere time length. ठीक है, यहां से हम ये बता सकते हैं. Okay, moving on to next. Okay, next topic is electric field due to a dipole. Electric field due to a dipole. If I place it for negative charge and a positive charge, okay. This is a small distance 2L, and let us take a point on the axis. Same direction में जो हमारा डाइपोल मोमेंट का है, ठीक है। यहाँ पे मैंने एक पॉइंट P लिया, ओके। नाउ फ्रॉम दिस डिस्टेंस टू दिस डिस्टेंस, फ्रॉम मिड पॉइंट ऑफ द डाइपोल, हम कभी भी मेजर करेंगे कहाँ से? वी विल ऑलवेज मेजर फ्रॉम द मिड पॉइंट, ओके। मिड पॉइंट ऑफ द टू चार्जेस, दो चार्जेस के बीच में जो लेंथ है उसके हम मिड से लेंगे, ठीक है, लेंथ। सो दिस लेंथ इज r, okay. Now what will be the electric field at point P? Point P पे electric field क्या होगा? I will not derive the whole formula because it will anyhow taking time. मैं डायरेक्टली फॉर्मूला दे दूंगा आपको जो हम अप्लाई करेंगे, ओके। तो इलेक्ट्रिक फील्ड एट पॉइंट P, that is axial, will be 1 by 4 pi epsilon naught into charge is, dipole के इसमें लिख रहे हैं 2p divided by r cube, 2p divided by r cube. This is the electric field on the axial or end point. You can say end point. You can find the electric field at this point also. That will be the same formula. On the axial, anyway we can find the electric field with this, okay, from this formula. If we take the vector quantity, if I take this into a vector quantity, what will be happen? This is a vector, right? यहाँ पे ये वेक्टर हो गया, तो हम डायरेक्टली लिख सकते हैं इसको E axial is equal to 4 pi epsilon naught 2p by r cube. Okay, next, electric field due to a dipole on bisector or equatorial line. Equatorial line means this is a negative charge and this is a positive charge, okay. There is a dipole with a distance of 2l. We are taking a point exactly in the middle like this, okay. This length is r, this length is r. Now what will be the dipole at this point P? At this point P, it will be electric field is given by equatorial line is equal to 1 by 4 pi epsilon naught into minus p by r cube, minus p by r cube. Here it is a positive and here it is a negative. Why negative? Why negative? Here it is a positive and here it is a negative. Why negative? Because at this point the electric field at this point on the equatorial will be opposite direction of the dipole, okay. Dipole direction कैसा है? इस डायरेक्शन में है और इसका डायरेक्शन कैसा होगा? इस डायरेक्शन में होगा, ओके. That's why it having a negative sign. यहाँ से नेगेटिव साइन मिलेगा. अब देखो इसको, देखो ये इस डायरेक्शन में है, इसको खींचेंगे कौन? इसी डायरेक्शन में खींचेंगे, इलेक्ट्रिक फील्ड, राइट, एट दिस पॉइंट. तो दैट विल बी इन द बोथ सेम डायरेक्शन. ये भी सेम डायरेक्शन में रहेगा और ये भी सेम, ये दोनों सेम डायरेक्शन में है और इट विल बी इन अपोजिट डायरेक्शन. दैट्स व्हाई वी पुट अ नेगेटिव साइन हियर टू मेक इट इनटू equal. Okay, these are two specific cases where we can get electric field. There is a what happens if we get other than these 2 points. If I place a point, it is not on axial as well as it is not on equatorial. मतलब एक्सियल पे भी नहीं है वो और इक्वेटोरियल पे भी नहीं है वो, तो तब कौन सा फॉर्मूला यूज आएगा? It will be given by electric field is equal to 1 by 4 pi epsilon naught into under root 1 plus 3 cos square theta divided by r cube. This is the formula. Okay. यहां से हम ये फॉर्मूला से हम क्या कर सकते हैं, इसको डिराइव कर सकते हैं. ठीक है. यहां से क्या है कि कोई भी पॉइंट चार्जेस, 2 पॉइंट चार्जेस नेगेटिव एंड पॉजिटिव, देयर इज अ पॉइंट P which is having a distance r from the center. It is an angle and making an angle of theta. Now, if we put the theta here, we will get the answer. Now, when will be our field maximum in an electric dipole and when will be our minimum? Maximum means when theta becomes 0, our cos will become 1, right? So that's why I am taking first case theta is equal to 0. So while putting this one, what will be getting our answer? 1 plus 3 cos square 0 divided by 4 pi epsilon naught r cube. So that will be cos 0 is 1 into 3 plus 1, that will be 4 into, sorry, okay, this will be given by under root 4 into P divided by 4 pi epsilon naught r cube. Okay. Now, what will happen? 2P by 4 pi epsilon naught r cube. This is the formula we got earlier. 2P by 4 pi epsilon naught r cube. That will be our formula for maximum. Minimum will be under root 1 plus 3 cos square theta 90 degree divided by 4 pi epsilon naught r cube. Cos 90 is 0, so 0 into P, that will be under root 1 into P divided by 4 pi epsilon naught r cube, that will be P by 4 pi epsilon naught r cube. This is a minimum. When theta is 0, we will get the electric field maximum. When theta is 90 degree, we will get minimum. So if they given 120 degree, 180 degree, then also you can find the electric field at that point from the